Hi, in this video I want to show how to solve various types of problems involving percent changes. Specifically, I'll show you how to solve these types of problems. Number one, given the starting value and the percent change, what's the ending value? This includes both the percent increase and the percent decrease. Number two, given the starting value and the ending value, what is the percent change? And number three, given the ending value and the percent change, what was the starting value? I will assume you already know the basics of percents. I have a video for that if you need it, but let's do a quick review. Question 1. Convert to and from decimal. 5% equals what in decimal? The decimal number 0.1 equals what percent? Question 2. Compute percent of a number. 8% of 9 equals what? Welcome back. Answer. From 5%, move the decimal 2 places to the left. The way I remember which direction is that it's moving to where the number appears smaller. 2 places to the left equals 0.05. The number 0.1. Move in the opposite direction. Move the decimal point 2 places to the right. Put in the percent symbol. The answer is 10%. Question 2. 8% of 9. In math, of means multiply. And 8% in decimal is 0.08. So 0.08 times 9 equals 0.72. Let's get started. First type of problem, given a starting value and the percent change, compute the ending value. Example, a hardware store is selling a power drill for $200. They decided to increase the price by 10%. What is the new price? Here we have a starting price of $200. Let's represent it by this blue bar that represents $200. We're adding 10% on top of it. The short red bar represents the 10%. How much will the new price be? Well, it'll be this total bar, right? Just stacking them up. Let's put in the numbers. The starting price was 200. The 10% of it is 20. The total of the two is 220. Answer, 220. Let's look at the answer more carefully. What's in this total bar? The long blue part is the starting price. All of it, 100% of the starting price. The small red piece on top is 10% of the starting price. The ending price of 220 equals 100% of the starting price plus 10% of the starting price, which then you can carry out the math, and we get our answer of 220. What do you think happens when the percent change is not 10%, but something else, let's say 4%? The diagram still looks the same, just that the 10% on top is now 4%. If we look at the math, the 10% becomes 4% throughout, but the 100% stays the same. Because when we do percent change, we must always start with the starting value, all 100% of it, all of it. The blue bar will always be there. Therefore, we have this formula. Ending value equals starting times parentheses 1 plus percent increase. Don't forget that when we calculate, we always put percent increase in decimal form. The 1 plus in this formula represents the 100% of the starting value. That's our formula. Now let's do another example. A baby elephant gains 8% of its body weight over a year. If it originally weighed 300 kilograms, what is its new weight? You can see the formula at the top. Go ahead, press pause, and try this. Welcome back. Ending weight equals starting weight times 1 plus percent change. Plug in the values. Starting weight is 300, percent change is 8%, which equals 0.08 in decimal form, equals 300 times 1.08. Compute it out, equals 324 kilograms. Now let's do a percent decrease problem. A factory has 80 workers. Corporate headquarters ordered a 5% reduction in the workforce across all locations. If the 5% decrease is implemented at this factory, what is the new number of workers? Let's diagram this out. We have a starting number of workers represented by our blue bar, and we're losing 5% of the workers. 5% of that is the smaller red block. We're told to subtract these people, meaning from the tall blue bar, we go down by the amount of the small red bar. The result is this final black bar. It's the same process, just that we go down instead of up. When we go up, we add. When we go down, we subtract, meaning going down means negative. Same process, same formula, just that the percent change is now negative. Let's do the math. The percent change is negative. Negative 5% equals negative 0.05. Applying the formula, ending equals starting times parentheses 1 plus percent change. Plug in the values. Starting value equals 80 times 1 plus, and now the percent change equals negative 0.05. Work out the algebra, equals 80 times 0.95 equals 76 workers. Here's our formula that covers both situations. Ending equals starting times parentheses 1 plus percent change, where an increase has positive percent, a decrease has negative percent, and don't forget that we always write percent in decimal form. Here are the couple of practice problems. I'll give you the answers. You should work on these on your own and see if you can arrive at the correct answers. Let's now do the second type of question, that is, given the starting and ending value, compute the percent change. Example, a movie grossed $50 million the first week. In the second week, the gross grew to $60 million. What was the percent change in box office earnings? Let me ask you this first. What was the dollar difference? The difference going from 50 to 60 million is 10 million. This is called the absolute difference. Just subtract. Whereas the percent change is also called the relative difference, and it's the difference not as a dollar amount, but as a fraction or percent of the whole. Therefore, the percent change should be equal to the absolute difference divided by the whole, divided by the box office earnings, right? Makes sense. Big question. Which box office earnings, though? Are we dividing by the 50 million or by the 60 million? To answer that question, let's go back to this picture. Back when we first started computing percent change, how did we compute the 10% increase? That $20 in the picture. We computed that 10% based on the starting value. The base of a percent change is always the starting value. So that's what we're going to divide by. The percent change is equal to the absolute difference of 10 million divided by the starting box office earnings. Plug in the numbers. 10 million divided by 50 million equals 0.2 or 20%. Let's check this answer. Is it really 20%? We started with 50 million. We claimed the increase was 20%. Let's compute the ending value and see if it equals 60 million. Ending equals starting times 1 plus percent change. Plug in the values. Starting equals 50. Percent change equals 20% or 0.2. Compute it out. Yes. Good. The answer is 60 million. We're now confident of our solution, and let's write it in the form of a formula. Here we go. The percent change formula equals absolute difference divided by the starting value. Always the starting value. What's the absolute difference though? Well, absolute difference was ending minus starting. Therefore, percent change equals ending minus starting, the whole thing divided by starting. Let's do an example. A family paid $350 in electricity a month. After moving into a more energy efficient apartment, they paid $245 in electricity a month. What was the percent change? There's the formula. Go ahead, press pause. Try this, then come back. Starting equals 350, and equals 245. Plug them in. Answer is negative 30%. Meaning a negative 30% change, which is the same thing as a 30% decrease, right? Negative percent change is a decrease. Positive percent change is an increase. Let's see what we've got so far. We have these two formulas. Formula for ending value equals starting times parentheses 1 plus percent change. Formula for percent change equals ending minus starting, the whole thing over starting. These two formulas actually are algebraically equivalent, meaning they are just one formula, just moved around algebraically. You can go from one to the other by doing algebra. So I do some more algebra. And I solve for a starting value, and I get this next formula. Starting value equals ending value divided by all of 1 plus percent change. So all of the 1 plus percent change is in the denominator. This is the formula I'll use to solve the third type of percent change problem. Number 3, given percent change and ending value, compute the starting value. Let's do an example. Sales tax. A customer paid $24.30 including taxes for a jug of detergent. How much was the price before taxes? And also, how much taxes did the customer pay? Here's the formula. Go ahead and try it. Press pause and come back when you're done. The percent change is 8% or 0.08. What about the 24.30? Is it a starting value or an ending value? It's an ending value because it's a value after we've added the sales tax. So it goes in the space of ending. Here we go. Plug everything in. 24.30 divided by 1.08 equals 22.50. So $22.50 was the price of the detergent before taxes. Not done yet. There's still this question. How much taxes did the customer pay? If you haven't answered this already, go ahead and press pause and try it now. Welcome back. There are two ways of answering this. One way is we figured out the original price was $22.50, but the customer paid $24.30. The difference between them must have been the tax. Tax equals $24.30 minus $24.50 equals $1.80. That's one way. The second way is we know the starting price now is $22.50. And we know the tax is 8%, so we just multiply 8% times the $22.50, and the answer is also $1.80. Let's do this practice problem. A young man needs to buy a suit for a job interview. He found one at 15% off. That now costs $212.50. What was the price of the suit before the discount? First, note that this is a discount, so it's a price decrease. That means the percent change is negative. Negative 15%. Go ahead, press pause, and finish this question. Welcome back. This is a question asking for the starting value. Applying the starting value formula, starting equals ending divided by 1 plus percent change equals 212.5 divided by all of 1 minus 0.15 because negative percent change, right? And we get the answer. All right, here's a summary of the three formulas. They're all actually the same formulas, just moved around differently using algebra. Let's now do something more advanced. Sometimes the quantities are themselves percent, such as unemployment rate, return on investment, interest rate, vote share, ownership portion, and then we're asked percent change questions on top of these percents. For example, if unemployment rate changes from 3% to 6%, what is the percent change? Think about it for a second. The answer is not 3%. Why not? Let me show you. Going from 3% to 6% is doubling it. When we double something, it's a 100% increase, not a 3% increase. Here's the right way of doing it. We need to recognize the percent that are quantities and not the percent change. The 3% and 6% are quantities, not percent change. Then we treat them as regular numbers without the percent. So the 3% unemployment and 6% employment in this case, think of it as just 3 and 6. Plain 3, plain 6, no percent. Here we go. If we think of them as just 3 and 6, we can plug it in the formula. Percent change equals ending minus starting, whole thing over starting. That equals 6 minus 3 over 3 equals 1, which in percent form is 100%. Correct answer. To avoid confusion, people distinguish between two things, the absolute difference and the relative difference. If you just subtract ending value minus starting value, that's the absolute difference. Here is 6 minus 3 equals 3. 3 what? We know it's not 3%. So this is what people call it. That absolute difference is set to equal 3 percentage points. When people say unemployment rate increases by 3 percentage points, they mean just the absolute difference. It goes from some number percent to another number percent that's 3 more than it. The percent change must be the relative difference, and it's equal to the formula we had. In this case, it should be 100%. When the quantity itself is a percent, we need to make clear which change we're talking about. When we just subtract, that's the absolute difference, and we must use the words percentage points. If we just say percent, it's supposed to be the relative difference or percent change. Let's do another example. An investment portfolio used to hold 10% of their assets in US Treasury bonds. The manager decided to increase the amount of US Treasury bonds by 20%. What percent of their assets will be in US Treasury bonds? You need to be careful which percent is which. There's a 10% here, there's a 20%, and there's a question that asks what percent. Let me ask you this. What is the question asking for? Is it asking for percent change, or starting value, or ending value? To answer that, you need to distinguish between the percents that are the quantity and the percent change. Go ahead and think about this, press pause, and come back. Welcome back. The 10% is the quantity, is the share of US Treasury bonds in the portfolio at the beginning. The 20% is the change, the percent change. We're increasing something by 20%. And what the question asking for is the final quantity, the final share of US Treasury bonds in the portfolio after the increase. The question is asking for the ending value. So we use the ending value formula. Ending value equals blank times 1 plus blank. Go ahead and press pause and fill in the blank and come back when you're done. Starting value is 10, percent change is 0.2 equals 12. The answer is 12% of their assets will be in US Treasury bonds. All right, that's the end. Here's the summary again. Hope this helps. Any questions? Ask in the comments section below. Like, share, and subscribe for more contents. And thanks for watching. Bye.